calculate. This is nothing but r square is here. This a square then hyperbolic square 1.2 theta, because this is r square here, plus dr d theta is this. This is a square upon 4 because square of this, and it is sec hyperbolic 4 1.2 theta. Why 4? Because this is the square of this. Dr d theta whole square is a square from 4 into sec hyperbolic 4 1.2 theta. Okay, so this is, let me solve it further. So a we can take common, even 4 can also be taken common, so it is a upon 4, a upon 2, sorry, a upon 2, it will come out, and a upon 2 here, because a square upon 4, if I take common outside the square root, then 4 into 10 hyperbolic square 1.2 theta will be there, plus this is nothing but sec hyperbolic 4 1.2 theta. This value is there. If I convert 10 hyperbolic square theta into cosec, that will be 4 into, this is nothing but 1 minus sec hyperbolic square theta by 2 or 1.2 theta, plus this is sec hyperbolic 4 over 4 1.2 theta. If I multiply this by 4 into this and then solving it, so now let me solve it here. Finally, ds d theta we are solving, this is nothing but a upon 2 out of the square root, and inside it is 4 minus 4 sec hyperbolic square, this is 1.2 theta, plus sec hyperbolic 4 1.2 theta, angle is 1.2 theta. Okay, so this is a perfect whole square. What it will be, this is a upon 2 square root, this is nothing but 2 minus sec hyperbolic square 1.2 theta whole square. Okay, so this whole square and square root is cancelled out. What is this? ds upon d theta, therefore is equal to a upon 2 into 2 minus sec hyperbolic square 1.2 theta. This is the only value of ds d theta. Okay, so therefore ds d theta is this. Finally, we have obtained this as this much. Therefore, length of the arc. Okay, therefore length of the arc we have to find out s. Therefore, s equal to, now let me put that here, because the limits are given to us. Therefore, s length of the arc is equal to limits 0 to 2 pi. These limits are given to us, into ds d theta into d theta. This is the value here. So ds d theta is this, which is nothing but a upon 2. Let me take outside, and this is 0 to 2 pi, 2 minus, this is sec hyperbolic square 1.2 theta into d theta. Okay, now let me further solve it. So what it is, if I separate it, it is s equal to, we are calculating here, s equal to okay, so ds d theta is this value. Let me write here, because ds d theta, will it be required? Okay, ds d theta is this value, a upon 2 into 2 minus this value is sec hyperbolic square 1.2 theta. This is value of ds d theta. This we will Okay, let me preserve it here because it will be required in case of area also. Okay, that value is there. So ds d theta. All right. So I mean this is ds d theta here. Now if I solve it further, it is nothing but multiplying this inside. It will give us 2 to cancel out, only a into d theta integration 0 to 2 pi. This is d theta here minus a upon 2. This a upon 2 0 to 2 pi into sec hyperbolic square 1.2 theta into d theta. They separated them. This 2 to cancel out, this d theta. If I just resolve it, it's nothing but a into theta limits 0 to 2 pi. This is minus, I'm not solving it, 0 to 2 pi. This is sec hyperbolic square 1.2 theta into d theta. What do we get? This is s equal to a upper limit is 2 pi, so this is twice a pi. The lower limit it will be 0 minus this I'm writing as it is. This is a into 0 to 2 pi. This is sec hyperbolic square 1.2 theta into d theta. This is, let me take equation number 3rd here. This 3rd I've taken here. This is the 4th equation. Let me take. Okay, this is the relationship between s, the length of the arc, and this value. Okay, now let me take area and delta or delta here, which is okay. Let me rub this. Now here delta is the area. Delta area is given by, we know that this is limits 0 to 2 pi. This is 1.2 into r square into d theta. R square into d theta. This is 1.2 into 0 to 2 pi here. What is r square? R square is this. This is a square into 10 hyperbolic square 1.2 theta into d theta. R square is this. Okay, so value of r square from first equation we have substituted here after squaring it. It is giving us a square upon 2 that we take outside, and this is 0 to 2 pi. If I put value of 10 hyperbolic, this is 1 minus sec hyperbolic square 1.2 theta into d theta. So if I further solve it, then what it will give us? This is delta here, area. For delta is this. Well, let me separate it. This is a square upon 2, the first value, and this 1 into d theta. Let me write d theta. This is 0 to 2 pi. Limits are same, 0 to 2 pi. Minus second part is a square upon 2 into 0 to 2 pi. This is second hyperbolic square 1.2 theta into d theta. This part is same, but having only a common. So I'll take a common, but before that, let me write it here. So delta is equal to a square upon 2 into this is theta. Integration of d theta or 1 is 0 to 2 pi minus a square upon 2 limits 0 to 2 pi. This is sec hyperbolic square 1.2 theta into d theta. Now what do we see here? Now if I take a common, and sorry, this theta is 2 pi, it is a square into 2 pi upon 2 to cancel out, minus a square upon 2, 0 to 2 pi into sec hyperbolic square 1.2 theta d theta. What do we see here? Now if I take, this is a square pi, if I take a common, it will be a pi here minus this is a upon 2 into 0 to 2 pi. This is sec hyperbolic square 1.2 theta into d theta. A I have taken outside. Now this value and this same, So let me take fifth one. This is delta equal to. This is the fifth equation. So from fourth and fifth, what do we see here? This value, and this are similar. So if I substitute the value of this from the second part, I mean the fourth one, this value is 2a pi minus s. In place of this, if I put 2a pi minus s, because this will come to this side. So putting value of s or this value, so from fourth and fifth, we get here delta is equal to a into a pi minus sign. So this value taken to left hand side and s to right hand side, it will be twice a pi minus s, and this is this value. What we have done, we have substituted the value of the integral a upon 2 into limits 0 to 2 pi sine of integration sec hyperbolic square 1.2 theta d theta. This value and this are same. So this value from fourth we have calculated. This is twice a pi minus s. We have substituted this value in place of this. This is a into a pi minus twice a pi, and this, now let me solve it. What do we see here? So we see here delta is equal to a into a pi minus twice a pi minus plus a plus s. So this is plus s, means a into s minus twice a pi plus a pi. This means minus a pi. So this is delta is equal to a into delta is equal to a into, where is the point? This one. Delta is equal to a into s minus a pi. S minus a pi. The same relationship we have obtained here. It means question second is also, question number 2 is also solved, is having the same relationship. Delta is equal to area is equal to a into s, where s is the length of the arc of the curve between the points 0 to 2 pi. Okay, this is the same value we have obtained. So question number question number 2 is finally solved. So second question is done. Second question is now completed. It has been proved. Okay, so this is question number 2. Now let me talk about question number 3. Question third says, what does question number 3 say? Question number 3, let me check. Now this is question number 3 here. This is the fourth one. Okay. Question 3 says, so that the length of the arc of the hyperbolic spiral r theta is equal to a, taken from r is equal to a to r equal to twice a, is this value. Is length of the arc s equal to a into within bracket under root 5 minus under root 2 square root 5 minus square root 2 plus log of 2 plus square root 8 upon 1 plus square root 5. This we have to find out, that this is the length of the arc between r equal to a to r equal to 2a of the spiral, hyperbolic spiral r theta equal to a. That is the point. Okay, so let me solve it. Question number 3 here. It says hyperbolic spiral. This is hyperbolic spiral r theta is equal to a. This is the first equation we are given. Second says the points length of the arc we have to find to show that length of this spiral, length of this curve, let me take of this curve between theta equal to, where is that? Okay, between r is equal to a to r equal to 2a is or s equal to, we have to find out, when root 5 minus root 2 plus log of 2 plus root 8 upon 1 plus root 5. This we have to prove. The length of the arc between r equal to a to r equal to twice a is given by this formula. Okay, so this is the point. Now let me solve it. Here r theta is equal to this. So solution. Here the hyperbolic spiral is, here r theta is equal to a, or we can say r is equal to a upon theta, or r is equal to a upon theta. That means this is a into theta raised power minus 1. This is value of r. Differentiating it, therefore differentiating it with respect to theta. Let me take with theta. We get this is dr d theta is equal to, this will be minus sine a into theta raised power minus 2. Simple. What is this? Minus 1 will come before, minus 1 into a into theta raised power minus 2, minus 1, minus 1. That is minus theta. That means this is nothing but minus a upon theta square. Now if I find out d theta, therefore upon dr, because we have to differentiate it with respect to r here, the limits of r are given. Okay, so this is d theta upon dr, therefore we can reverse it. This is minus theta square upon a. This is the value here. D theta upon dr is this value. Okay, therefore length of the arc we have to find out. Therefore length of the arc between r equal to a to r equal to 2a is given by, is given as s equal to sine of integration. This is 0 to, sorry, a to 2a, I'm sorry, this is a to 2a, r is equal to, now ds upon, we have to find here ds upon dr into dr. The ds upon dr we have to find out. Now let me find out what is ds upon dr. Okay, this is dr upon d theta upon dr is minus theta square upon a. Let me now find out what is ds upon d theta, ds upon dr, sorry, because this ds upon dr we have to find out. So therefore ds upon dr is equal to, we know that this is square root of 1 plus r into d theta upon dr whole square. This is the value. Therefore this can be calculated as 1 plus r square into d theta upon dr whole square, d theta upon dr whole square. What is this value? We can get here d theta upon dr is this minus theta square upon a square. Let me put it here. So this is nothing but 1 plus r square here. R square is a upon theta square, or a square upon theta square, because r square from first equation. Okay, r theta equal to a, so r is equal to a upon theta is square here, into d theta upon dr is this. This is minus theta square upon a whole square, d theta upon dr whole square. Now it will give us the value required. Okay, now let me solve it further. So it will give us here, we are finding out ds upon dr. So this is the solution. Let me further solve it. A square upon theta square into theta 4 upon a square cancelled out. 1 theta square is also, so this is 1 plus theta square. It is nothing but square root of 1 plus theta square here. Okay, so 1 plus theta square is there. This is the value of ds dr. Okay, alright. Now let us take this value here. But theta we will substitute finally in terms of r. because this we have to differentiate with respect to r. So theta is here, but theta is not to be required because r is to be required, because we have to integrate with respect to r here. Therefore, now let me finally substitute. ds upon dr is this. Therefore, s equal to length of the arc is equal to a to twice a ds upon dr into dr. ds upon dr is this value. It will give us a to 2a. ds upon dr is the square root of 1 plus theta square. Now theta square is from this a square upon r square. From first, since theta is equal to a upon r, theta square will be a square upon r square. This a square upon r square. This is value of theta. Or theta square is a square upon r square into dr. Okay, now this is converted into r, because integration is with respect to r. So we have converted theta into r only. Now let me solve it further. This is a to 2a. Here it is under root r square plus a square upon r. Square root from r square is cancelled out. This is dr here. Okay. Now we have to integrate this. So integration of this can give us, if I put, okay, here let me put r is equal to something 8 tan theta. If I solve it, then it will be integrated. Now let me solve it further. So r under root r square plus a square, if I put some value here, or we can resolve it because this is r square plus a square. So if I put r equal to 8 tan theta, then it can be, square root can be taken out. Now let me solve it further. So what is the value of this? It will give us, okay, so this value is, and limit can also be changed into, if I put r square plus a square into t, let me take t, not to put like that. Okay, let me put r square plus a square equal to t square. Putting r square plus a square equal to t square. Therefore, differentiating it with respect to theta, t, differentiating it with respect to t, we get twice r into dr equal to twice t into dt, or r into dr equal to t into dt. This value of this. What are the limits here? Limit, let me find out. That r is equal to a, r equal to a here. Okay, r is equal to a. So this is twice a square. So t equal to under root 2 into a, or a under root 2. At r is equal to a. Let me take twice a, upper limit. R equal to twice a, t square equal to 5a square, or t is equal to a under root 5. And at r is equal to a, t square is equal to twice a square. Why? Because a square plus a square. Here is this one. This. If I put r equal to a here, lower limit, a square plus a square is twice a square, t square equal to twice a square, or t equal to a under root 2. This is t square equal to twice a square, so t equal to a root 2. Lower limit is a root 2, upper limit is a root 5 in terms of t. This we have put as t square. Okay, so now this is r square here. We can multiply this by r and divide by r. It can be, let me further write it as a into twice a to twice a. This is under root r square plus a square upon r square into r dr. No change. What we have done, we have multiplied by r in the numerator. In the denominator also we have multiplied by r. So in the denominator we have r square. In the numerator we have r into dr. Okay. Now we can substitute the values, which is very simple now. So therefore S length we are calculating. Therefore S is equal to limits now. Lower limit at A was A under root 2. Upper limit was A under root 5. Okay, and this is T, because under root R square plus A square is square root of T square, that means T only. This is T into T dt, because R dr is T dt. Here it is R dr equal to T dt. In place of R dr we have put T dt divided by R square. R square is T square minus A square. It is nothing but T square minus A square. Now we have to solve it. Now let me solve it further. Okay, so now this is T square in the numerator. A root 2, A root 5. This is T square into dt upon T square minus A square. Now if I further solve it, then subtracting A square and adding A square, no change, divided by T square minus A square into dt. So I can separate it. This is A square, A root 2, sorry, to A root 5. This is 1 here. T square minus A square upon T square minus A square is dt only, plus this is A square into dt upon this is A root 2 to A root 5 limit, and this is 1 upon T square minus A square, the second part. So dt upon T square minus A square. Now this is to be integrated by partial fraction. Now let me integrate the second part. This is simple integration. This is only T, limits are substituted then. Now let me solve it here. What do we get here? Therefore S is equal to, first integration of 1 into dt is T only. Limits A root 2 to A root 5 plus. Now this is A square. Here it is A square. We can write it as A root 2 to A root 5 limits, and this is dt upon T minus A into T plus A. We have to integrate this part, second integral. This is I1 and this is I2 suppose. So I2 is, in terms of partial fraction, we have to resolve it. So now let me solve it with the help of partial fraction. How do you solve it? Let me solve it now. So by partial fraction, the second part can be solved with the help of partial fraction. Okay, so first is, let me first solve it. Putting limits, this is A, let me take comma, this is root 5 minus root 2, first part is integration. This is A square, let me now solve it, the second part. A root 5, A root 2 to A root 5. This is 1 upon, let me take T minus A into T plus A into dt. Okay, now let me solve it. So let 1 upon T minus A into T plus A is equal to A upon T minus A plus B upon T plus A. Okay, this is by partial fraction. By partial fraction. Using partial fraction. Partial fractions. So by partial fraction, we have to solve it. So we have to find out the values of constant A and B. So how? Direct method, let me apply. We have done this in detail in case of partial fractions. Please see my lecture series in partial fractions. I think 34 or 35 total lectures in that series I have completed. Please go through that, how partial fractions are done. That is a very important topic, because to integrate this kind of questions, when T square minus A square is given in the denominator, you can use the partial fraction. Okay, this is partial fraction now. So how to solve it directly? To find value of A, what we do? We put the denominator of this T minus A to 0, equal to 0. T minus A equal to 0, then T equal to A. Substituting T equal to A in the left hand side, except this one, T minus A. Because if I put T minus A 0, then 1.0 is infinity, then it will not be defined. Well, to find value of A, we equate this equal to 0, T minus A equal to 0. finding value of t, which is a, t equal to a. Substitute the t equal to a other than this factor. So in t plus a we have to put t equal to a. This is 1 upon a plus a. That means 1 upon 2a. So a is equal to 1 upon 2a. This is the direct method. And for b, value of b, what we do? Again, t plus a equal to 0 or t equal to minus a, we have to substitute t equal to minus a in the left hand side other than t plus a. In this, if I substitute 1 upon t minus a, t is minus a, because t minus a, t equal to minus a, we have to substitute here. So in place of t, if it is minus a, minus a, minus a is 1 upon minus 1.2a. b is minus 1.2. Simple. Or we can solve it by equating, by making equation. If I cross multiply by this denominator to the left hand side, it will be 1 is equal to a into t plus a plus b into t minus a. Now solving this equation by equating coefficients. The coefficient of t, if I equate, in the left hand side coefficient of t is 0. This is a plus b. The coefficient of t in the right hand side is a plus b. In the coefficient of constant, left hand side is 1. Here it is t a into a. That means it's small a into a. Plus this is minus a into b. Coefficient, constant coefficient. I'm solving these two equations. If I multiply the first equation, this by a, let me take. If I multiply by a, this is a and this a. Okay, in the first we have multiplied by a. Now adding them first and second. So here it will be 1 equal to twice a into a. This is 0 here. ab minus ab 0. Therefore a is equal to 1 upon twice a. This is right. And if I put this value of a 1.2a in any equation, first one that we take. So this was a plus b equal to 0. If a plus b equal to 0 and a is 1.2a, then b equal to minus 1.2a. Simple. That is another method. Okay, so with the help of these two, we have calculated the coefficient values. What is there? Therefore, finally, so this integral is changed into two parts. This is plus a square, and this is the first one, a root 2 to a root 5. Value of a was 1.2a. This was, let me take 1.2a outside. This is a square 0.2a into 1 upon t minus a into dt. Minus second part is, it is a square upon